So first thing we're going to go over today is evaluating logs. We did talk about evaluating logs a little bit last time. We had examples where you had log base 2 of 8. So I told you what you needed to be thinking in your head is what is the exponent on a 2 that gives you an 8? And we would all say 3. So we were evaluating some of the easier ones in our head. And then we got to some that we couldn't quite, and I told you, I'll show you how to do that next time. Well, it's next time. So if we have the common log and we have to evaluate them, all we need to do is use that little log button in our calculator. So for example, log 10, log is over here. You just push log 10 and then hit enter. So then the calculator evaluates it for us. Log 10 is 1. So go ahead, type in that next one, log of 0.001. Log of 0.001 gives us -3. So what's log 1? 0. Last one, you're going to get a decimal, log of 465. Ooh, 5. Round to the nearest 10,000th, so the 4 rounds up to a 5, so there's a 5 after it. Okay. So sometimes they use the natural log, which is ln. We're going to talk more about natural log, but evaluating is pretty easy because ln is right in your calculator beneath the log button. So our first one is the ln of e. So I just push ln. Do you guys remember where the e button is? Second, ln gives you e. It does always open an exponent. So yeah, we got to put an exponent of 1 in there because they just wanted e to the first, which is 1. So I go ahead and type in ln of 5. (1.6094) ln of 1, 0. So ln button works just like your log button. And then any other base. So this was the new one I showed you before we did our warm-up. You just go to the math button, go to the log base. Math. Log base. 2 of 8. So we get 3. So log base 3 of 5. Gives us 1.4649, so that's 1.4650. Okay, so then log base 5 of 0.3, what do we get? So again, evaluating, calculator will do that for you. These ones were telling us to the nearest 10,000th. Sometimes it's nearest 100th, it'll tell you. If it doesn't tell you, then just copy whatever the calculator gives you. So then the other one is the anti-log. Anti-log really just is the opposite of finding a log. So we were actually doing this last class. So what is our base on log if there's no number written? 10. So what would we do to figure out n? We would take it from log form and put it into exponential form. So this would become 10 to the 3.9370. And it would equal your n. So the anti-log in your calculator, which is simply pushing second and then log, just sets up the 10 and then the exponent spot for you. It's just a little shortcut to make that process a little bit faster. So then 3.9370. 8,649.68. Well, this one says nearest 100th. So again, antilog is just a shortcut to give you your 10 to the exponent spot. Second one, you would want 10 to the negative 1.8765, putting it into exponential form. Go ahead, type that in. What do we get to the nearest hundredth? 0.01. Is question number 3 even an antilog question? No. See, if I cover up this n equals, it's just like those other ones we were doing. So you would just type in log 1/4. And again, to the nearest hundredth. No. Some yes, these ones no. What do we get? No, back in the day, no. No. So what do we get for this one? Negative 0.60. It's just regular, because remember, if we cover up the n, it's just like the other ones we were doing, so you're just evaluating. So you would just hit log and then 1/4. And then 4, again, take this and put it into exponential form. You'd get 3 to the negative 2, which is 1/9, which as a decimal would be 0.11. So, reviewing again from last time, log simply means we're talking about the exponents, just a fancy word that means exponents. Log properties is what we have to deal with next. They mimic your exponent rules. So if you recall exponent rules, if I am multiplying 3 to the x times 3 to the 5th, what do we do with those exponents? We add them, so it becomes x to the 8th. So if we're multiplying two things with logs, so for example m times n, that means we would add the logs together, because again log means exponents, so you're adding the exponents together just like you would in your other problems. Quotient rule. So let's say I have x to the 6th divided by x to the 2nd. What would we do with our exponents now? Subtract them, so we get x to the 4th. Same thing happens with our logs. So if you are dividing two things, you would subtract their logs. So you're subtracting their exponents from each other. Our power to a power rule. So if you had two exponents on one thing, so 3 to the, or x to the 3rd and then to the 2nd, you'd multiply them. So we got x to the 6th. Same thing happens here, but what we do is we move our exponent in front of the word log, and then we multiply them. So it would be the exponent times log of whatever. So you're multiplying your two exponents. You have exponent times exponent. So the equality of logs, we're going to actually deal with that a little bit more next time. We're going to focus on these first three, our product, quotient, and power rule. So what we have to do with our logs sometimes is we have to take it and we have to expand it out, because it's going to help us eventually solve a bigger problem later on. And then sometimes we have one that's expanded, and what we need to do is we need to condense it down, again, to help us solve a bigger problem later on. So all we're going to do for today is we're going to practice expanding and condensing so we can get to the bigger stuff later on. So when we are expanding, our order is we deal with any quotients first, then we deal with products, and then exponents come last. So quotients, products, exponents. That is our order we follow when we're trying to expand it and make it larger. So looking at our first example there, I have log of a squared. So we're looking at just everything after the word log. So we're looking at our a squared. There's no quotient there. There's no product. That one's just an exponent. So our exponent of 2 is simply going to come down in front of the word log, and it's going to become 2 times the log of a. So 2 is the exponent. Log means exponent, so exponent times exponent. So our next example, we have the square root of z. We need to rewrite that using the fraction exponent, so z to the 1/2, remember, is the equivalent of the square root, power over root. So now it's the same thing. We look at the z to the 1/2. There's no quotient. There's no product. This one is just an exponent 1 again. So our exponent comes down in front. So we get 1/2 log base 5 of z. And then there's nothing else we can do for that one. So our next one, we then have more. We've got a numerator, denominator, so we have a quotient there. We also have a product in our numerator because it's 2 times x. You have your exponent in the denominator. So our quotient comes first. So log of your numerator minus the log of your denominator. So log of base 5 of 2x minus log base 5 of y to the 3rd. Quotient is then taken care of. So now we are moving on to the product, and again, 2x really means it's 2 times x, so that is a product. So that's log base 5 of 2 plus the log base 5 of x. You separate that out and you add their exponents together by adding their logs. And it's still minus the log base 5 of y to the 3rd. And we still have one last thing to do, and that's our exponent. So this 3 just needs to come in front of the word log on the y, not in front of all of them. So log base 5 of 2 plus log base 5 of x minus 3 log base 5 of y. So the exponent comes in front of just that log term. So then our next one, again, I'm going to rewrite this first to get rid of my cube root. So it becomes 10 times x to the 1/3 over bc. Same thing, again, just different way of writing it. So we have a quotient, so we got to do our subtraction first. So log of the numerator minus the log of the denominator So now we have product rules. We have it twice actually. We have 10 times the x to the 1/3, and we also have the b times the c. The log of 10 plus log of x to the 1/3 minus the log of b plus the log of c. And those are in parentheses because b and c were both in the denominator. So that whole thing has to be subtracted there. And then we're not quite done yet. Log 10, that's one of the ones that always needs to be simplified because what does log 10 equal? 1. So whenever possible, you've always got to simplify them when they're one of the quote-unquote easier ones to simplify because it becomes a whole number. Oh, my exponent on my x comes down in front. So that becomes 1/3 the log of x. You can bring the negative sign through those parentheses and make it minus log b minus log c. That's another way that you can write it. Or you can leave it as minus and then your parentheses, log b plus log c. All right, so now we're going to go the other way. It's expanded out. We need to condense it. When we're condensing, it just goes in backwards order. So exponents are first, then your products, and then your quotients. So anytime you have a number in front of the word log, that is always an exponent. So that means 1/2 is an exponent, 4 is an exponent. So I would have log of a to the 1/2 minus the log of c to the 4th. And then because I'm subtracting there, what's actually happening? Division. So it's the log of a to the 1/2 all over c to the 4th. You may see on some problems where they turn it back into a radical around the a. Either one is fine. So looking at the second one, 3 is an exponent because it's in front of the word log, so I'm going to bring that up first. So after exponents we have products. I have a plus sign, so that means I do have a product here. It would be z to the 3rd times the 4x minus 3. So minus my log base 2 of x. And then that log base 2 of x is being subtracted, so that means I'm actually dividing. So that ends up being our final answer, z to the 3rd times 4x minus 3 all over x. So for this one, they're telling you to rewrite these in different terms. They tell us anytime I see a log 2, they want us to replace it with a. Log 3, they want us to replace with a b. Log 10 simplifies down to a 1. So looking at our first example, I'm going to use my rules of expanding because those two things are being divided. That means I want to actually subtract their logs, so log 10 minus the log of 9. But because our problem talks about log 2 and log 3, 9 doesn't really help me out too much. So how can we rewrite 9? Nine would be 3 squared. There's another way we can write 9. So my exponent would come in front, so minus 2 log 3. Now it's expanded out as far as I can possibly go. I'm going to start substituting things in. Log 10 is 1. Log 3, they told us to use a b. So we get 1 minus 2b. All right, next one, 60. We got to first break apart 60, figure out what numbers multiply to give us 60 that we could actually use, because again, we have log 2, log 3, and log 10, so we got to use those numbers instead of 60. So what are two things that multiply to give us 60? 10 times 6, and then 6 breaks apart into 2 times 3. So the other way we could write 60 is that it's 2 times 3 times 10. Still equals 60. Just write it in a different way. So what is our rule of logs when I'm multiplying things? Yep, add the log. So the log of 2 plus the log of 3 plus the log of 10 So now that we've gotten down to 3's and 10's, let's plug things back in. The log of the log of 2 is a. Log of 3 is b. Log of 10 is a 1. So we get a plus b plus 1. All right, 30 could break apart into 3 times 10. And then 4, how can we rewrite 4? 2 times 2, also known as 2 squared. So I would have the log of my numerator, which is 3 times 10, minus the log of my denominator, which is 2 squared. Because again, we broke apart the numbers to be able to simplify things. So this would give me the log of 3 plus the log of 10. And then minus 2 log of 2. So again, now we'll plug back in. Log of 3 is b. Log of 10 is 1. And then minus 2a, because it's 2 times log of 2, which is a. All right, so let's try some more. They're changing our rules up now. Next example, log base 5 of a is a 2. Log base 5 of b is 7. And then log base 5 of c equals a 1. So the problem they give us over there, let's get rid of that square root sign, write it as an exponent. There weren't any rules dealing with the square roots. We need the exponent. So then we'll expand things out. Making sure you remember to keep writing your base in there. So base 5 always has to be there. So let's look at just the stuff from the numerator. So the a to the 1/2 and the b. If we expand that out further, what would that look like? There we go. 1/2 comes out in front because it was an exponent. So 1/2 log base 5 of a plus log base 5 of b minus 2 log base 5 of c. Now we can plug our numbers in. A, they told us to use a 2, so it'd be 1/2 times 2 plus a 7, and then minus 2 times 1, because they told us log base 5 of c was a 1. So we combine those all together, what do we get? 6. All right, next one, log base 3 of 2 is k. Express log base 3 of 18 in terms of k. So again, we have to break apart 18. So what multiplies to give us 18? 2 and 9. And then 9 can go further and become 3 and 3, or 3 squared. So we would have log base 3 of 2 times 3 squared. So I break apart my 18, 2 times 3 squared. So that would become log base 3 of 2 plus 2 log base 3 of 3. So now we can substitute it in. Log base 3 of 2 becomes k. They told us up above that that equals k. Log base 3 of 3, what does that simplify to? What's the exponent on 3 that gives you 3? 1. So then 2 times 1 makes that a 2. Anytime in logs, if this number and this number are the same, it's always a 1, because the exponent on any base to give you that same answer is 1. So looking at our next one, how can we rewrite 8? It talks about a 2 over here, so kind of gives me a hint that I'm going to deal with 2, so 2 to the 3rd. How can we rewrite 27? 3 to the 3rd. And we got our log base 3 in front of it still. So expanding that out, what would that become? Yep. Minus 3 log base 3 of 3. Exponents always go in front. Division means we subtract. So again, log base 3 of 2 becomes a k. So that becomes 3k since there was a 3 out in front of it. Minus log base 3 of 3 becomes a 1. So 3 times 1 makes that minus 3. So 3k minus 3. All right, 2 more. So 75. What multiplies to give us 75? 3 times 25. So how can I rewrite 25 though? 5 squared. The 9, 3 squared. So expanding this out, I got the log base 5 of 3 plus 2 log base 5 of 5 minus 2 log base 5 of 3. So then those log base 5s of 3s, those are going to turn into a's. Log base 5 of 5 simplifies to 1. So 2 times 1. And then subtract my a's, a minus 2a. Will give us negative a. And then last one, 700. How does 700 break apart? Seven times 10 squared. So it'd be 7 times 100. 100 is 10 squared. So we would have log 7 plus 2 log 10. They told us log 7 turns into c. 2 log 10 would simplify to 2. So c plus 2.